Hi everyone. In this video, I am going to discuss about the concept of the important problem types, which is mainly to focus on in computer science field. There are seven different kind of problem areas we are mainly to focus on in computer science area. One is sharding, second one searching, string problems, graph related applications, combinatorial problems, geometric problem, then numerical problems. So these are the some of the problem major. I mean, so these are the major seven different area of a domain. We need to concentrate once if you want to know about the computer science field. So the first one, it is a very important thing that is called as a sorting. So we know that the main goal of this is sorting is this: we are going to make the list of items in either an ascending order and a descending order. For in a particular record, we are going to use some kind of the information in the record for searching. For example, I have a student database. I'm going to make a list of student records arranged in either alphabetical order or maybe I mean either in ascending or descending order, either with the help of the name or with the help of a roll number or with the help of register number. So in the particular, the field of the information will be considered, will be processed for ordering an items in the set. அப்போ ஒரு லிஸ்ட் ஆஃப் செட் இருக்கு அப்படின்னா அதுல இருக்கிற லிஸ்ட் ஆஃப் எலிமெண்ட்ஸ் நான் ஆர்டர் பண்ணணும் அப்படின்னா ஏதாவது ஒரு பர்டிகுலர் டைப் ஆஃப் இன்ஃபர்மேஷன் எடுத்துட்டு நம்ம என்ன பண்ணலாம் அப்படின்னா ஆர்டரிங் பண்ணலாம். So the main goal of the starting problem என்ன அப்படின்னா we are going to make the either in ascending a list of items either ascending order or descending order. For that we are going to use the basic operation is either comparison or swapping. So comparison அல்லது swapping யூஸ் பண்ணி தான் நம்ம என்ன பண்ணணும் அப்படின்னா comparison is the major concept, major basic operation for making the list of elements in either ascending order or descending order. Along with that, in some kind of that, we need swapping. But we can't say that in all the application must follow the concept of swapping. எல்லா algorithmவும் swapping follow பண்ணாது. So these are the some of the algorithm, the existing algorithm we have, which is related to the sorting. One is a bubble sort, insertion sort, selection sort, merge sort, quick sort, heap sort, shell sort, and bucket sorts. Normally, these sorting algorithms are means that processed or maybe compared based on these two properties. அதாவது ஷார்ட்டிங் அல்காரிதத்தை கம்பேர் பண்ணணும் அப்படின்னா ரெண்டு ப்ராப்பர்ட்டிஸ் நார்மலா வந்து we have to follow. One வந்து பாத்தீங்க அப்படின்னா it's a stable property and second one is called as a in place property. So normally if you are saying it is a stable property, it means that the order of the elements need to be preserved. அதாவது என்னன்னா we are going to preserve the relative order of the same items in input. அதாவது ஒரு லிஸ்ட்ல ஒரே நம்பர் more than one time இருக்கு அப்படின்னா அதோட ஆர்டர் வந்து மாறக்கூடாது. ஃபார் எக்ஸாம்பிள் இஃப் த இன்புட் லிஸ்ட் கண்டெய்ன்ஸ் டூ எலிமெண்ட் த பொசிஷன் ஐ அண்ட் ஜே. ஸோ என்ன அதாவது இன்புட் லிஸ்ட்ல வந்து த பொசிஷன் ஆஃப் த ஃபர்ஸ்ட் எலிமெண்ட் ஐ லெஸ் தென் ஜே இருக்கு அப்படின்னா தி சேம் கண்டிஷன் நீட் டு பி மெயின்டைன்ட் ஆஃப்டர் ஷார்ட்டிங். ஃபார் எக்ஸாம்பிள் அதாவது ஈஸியா ஷார்ட் இது புரியணும் அப்படின்னா இப்போ எனக்கு சம் வேல்யூஸ் இருக்கு 45, 67, 69, 34 and 56. So assume this is the number. So for after starting on the pattern, so we know this is a position. So everything will be indexed by referenced by the index. So 0, 67 is located in 1, 69 is 2, 34 is 3, and 56 is 4, and this is 5. After starting, இப்போ நான் after start பண்றேன். After start பண்ணதுக்கு அப்புறம் என்னோட ஆன்சர் வந்து பாத்தீங்க அப்படின்னா 34, 45. Now, so here the same elements is not exist, so I'm going to make it as a 56. So it is a 56, again 56, 69, and 78. So for this case, now I'm going to make it as an order. I'm going to give the index 0, 45 is 1, 56 2, and this is 3, and 69 4, and 5. So இதில் வந்து பாத்தீங்க அப்படின்னா ஷேர் பண்ணும்போது so this assume that initially the value of in this case the value of I equal to 1. Here the index of the value is I equal to 1 and j equal to 4. Because the same order of the same elements, the same items, so the same item 56 is repeated 2 times, so that the first position will be considered as I, so that the position I is 1, here j equal to 4. So for this case, I is less than j. After the sorting, So this 56 வந்து பாத்தீங்கன்னா it will be located on second position, and this 56 will be related on j position, so that for this case the value of I equal to 3 and j equal to 4. So now the condition is I less than j, so it will be matched. So this is called as a stable property. Just we are going to preserve the relative order of the same item. அது ஒரே மார்க்க வேல்யூ more than 1 இருந்தது அப்படின்னா அதாவது எந்த ஆர்டர்ல வந்து நம்மளோட லிஸ்ட்ல இருக்கோ அதே பொசிஷன் ஆர்டர்ல இருந்துச்சு அப்படின்னா then it will be called as stable property. So here the position same இருக்கணும்ங்கற necessary இல்ல, but the first elementல இருக்கிற location வந்து second same element இருக்கிற location ஓட less இருக்கும். That is the meaning. And next one is called as the in-place property. So in-place property it is related to the space complexity. அதாவது algorithm நம்ம solve பண்றதுக்கு maybe the algorithm won't take extra memory, or it takes a more some fewest amount of memory அப்படின்னா then it will be coming under in-place property. So already we know that no, so the the merge chart வந்து பாத்தீங்கன்னா not coming under in-place property because we need n number of additional memory spaces for solving a merge chart. So that merge chart not coming under in-place property. But maximum all the algorithms is coming under stable property. So now just I'm going to discuss about the complexity. So that the complexity of the bubble chart is approximately big O of n square. So that is a big O of n square. And same way for insertion chart is also on the same case. Insertion also same case. Selection chart is also in same case. For merge charts, it is a big O of n log n base 2, because we are going to divide the problem into two cases. But here it will be an n log n for an average case. For a quick shot, n log n for average case, if the input number is not in ascending or descending order, if it is either an ascending order, in the worst case, it takes n squared complexity. For a heap shot, it takes a big O of n log n. And for shell chart maximum, it depends on that. There are different complexities there. Big O of n is also possible, n log n is also possible. Bucket chart, but it is not coming at it because we need more amount of memory. But actually for that we need only log n property, log n space, because it depends on the number of digits. So that the log n complexity, n log n complexities we need because the digits based on the digit will work, so that it will work for n log n. It is also maximum the complexity will be related to n log n. So these are the some of the complexities was related to the sorting. So from that we can easily to predict that that is even for merge chart, only the problem in a merge chart is the memory spaces. That means that we need additional memory spaces so that merge chart is not coming under in-place property. Even bucket sort is also not coming under in-place property. Bucket sort of the in-place property because we need more amount of memory. So the the sorting algorithm நம்ம evaluate பண்றதுக்கு இந்த ரெண்டு ப்ராப்பர்ட்டி தான் நம்ம மேக்ஸிமம் ஃபோக்கஸ் பண்ணுவோம். ஒன்னு வந்து ஸ்டேபிள் ப்ராப்பர்ட்டி, another one is in place property. ஸ்டேபிள் ப்ராப்பர்ட்டினா preserving the relative order of the same item. இதே வந்து in place propertyனா additional amount of memory வந்து ரொம்ப அதிகமா எடுக்காம நம்மளால சால்வ் பண்ண முடிஞ்சிச்சு அப்படினா it is coming under in place property. So sorting is the major application important area in computer science field. The second one, searching. So already we know what is searching. Searching means it is a process of finding the particular element in the list. So ரெண்டு possible outcome இருக்கு. Either வந்து the element exists இருக்கலாம் or not exist இருக்கலாம். So that the basic operation வந்து we are using comparisons. So normally there are two type of algorithm normally we prefer to use in searching algorithm. One is a linear search or maybe a binary search. Linear search means that we are going to search from the first index to the last index. So if the number of elements வந்து அதிகமா இருந்தது அப்படினா the complexity of the linear search is high. So for the best case it is a 1 if the element first exists, element exists first exists. இதே in case வந்து worst case அப்படினா maybe the element is not exist, or it may be or the element present at the end of the list அப்படினா it is nearer to n, and for average case it is n. That is n plus 1 by 2, so generally it will be represented by n. For the binary search, the condition enna appadina, that is a mandatory, that is a prerequisite. The prerequisite enna appadina, the input elements either in ascending order or descending order. So input elements must be in either ascending or descending order. Either descending, இந்த ரெண்டு ஆர்டர்ல ஏதாவது ஒண்ணுல தான் இருக்கணும். இருந்தா மட்டும்தான் binary search applicable. So that the complexity for binary search என்ன அப்படின்னா because log n தான், because we are going to divide into two problems, so that log n base 2. ஒரு half மட்டும் தான் எடுத்துக்கிறோம், ரெண்டு half எடுத்துக்க மாட்டோம், so that it coming under log n. So I means that we are going to implement as a recurrence about பண்ணலாம், so that simply we can say that it is n by 2 plus 1, because one need additional comparisons we need, and if the number of elements is 1, there is no need for any comparison, so that's 0. So next one is called as a string processing. Sorry, only one comparison we need, so that it is 1. Okay, for a string processing, we know what is a string. Already we know that a string means that it is a collection of the sequence of either it may be characters or digits and alphanumerics, or the special characters to be stored in a continuous memory location. In a single name, it will be called as a string. So the processing of a strings in C and C++ language is difficult, but in Java and all, it will be made, the input itself is into concentrations. So that the processing of strings is very, very important. So some of the application like string matching problem, string reverse, string concatenations, these are all some of the applications will coming under string processing. And the next one is called as a graph problem. So we know that the graph is normally it is defined as collection of edges and vertices. G normally will be, G means it is a graph. So normally it will be represented with a set of vertices and edges. So normally in many real-time applications are represented with the help of in a graph. For example, transportation problem like Google Map. Communication networking, that means that for creating shortest path in mapping, means for sending packets and all we can use. And for games, it will be work with the help of node. And even for scheduling of the different kind of applications is coming under graph applications. So normally many type of real applications are connected through graph. So that just we are going to, with the help of graph oriented applications, we are going to solve this real application for this kind of real applications with the help of graph representations. And the next thing is combinatorial problem. Actually, it is also called as a decision problem. இதை வந்து நம்ம வந்து decision problem அப்படிங்கறதோட சொல்லலாம். So the major goal of this decision problem is we are going to find like the grouping, or maybe we are going to make some ordering, or we are going to make some assignments. But இதுல வந்து பாத்தீங்க அப்படின்னா it is a collection of, first of all you must know the terminology is called a feasible solution. FEA is feasible solution. Feasible solution அப்படின்னா it provides, it is one of the solution for the problem. Actually அது இது ஏன் decision problem அப்படிங்கிறது சொல்றோம் அப்படின்னா along with the problem constraint we have some extra constraints இருக்கும். For example, we'll just take a traveling salesman problem. We call as a TSP, traveling salesman problem. So the constraint enna appadina for the traveling salesman problem, or normally it will be represented with the graph notation, so that all the vertices must be visited once, must be visited only once, and the input must be as weighted graph. Weighted graph ada irukonu, it may be a directed graph or undirected graph. Only once da irukonu, and the starting and ending vertex must be same ah irukonu. Starting and ending vertex must be same. And the third, it is coming under optimized solution. It will be a shortest cast path cast இருக்கணும். So these are some of the constraints. So நம்ம ஒரு ப்ராப்ளம் சொல்யூஷன் பண்ணும்போது இதை வச்சு நம்ம ஒரு ப்ராப்ளம் சொல்யூஷன் பண்ணலாம், பட் வர ஆன்சரோட காஸ்ட் வந்து மினிமமா இருக்கணும் அப்படிங்கிறது கண்டிஷன்ஸ் இல்லை. But minimum இல்லைன்னா நிறைய வேல்யூஸ் நம்ம அனாலிசிஸ் பண்ணாதான் ஃபைண்ட் பண்ண முடியும். So that from these are means for possible solution for the problem is coming under feasible. Optimized solution அப்படின்னா it's the best solution for the problem is coming under optimized solution. So that optimized solution கண்டுபிடிக்கும் போது we are going to map with the decision certain controls with the properties. So that these are the problems are coming under combinatorial problem. For example, let us take a graph coloring problem. That is a graph coloring problem. You are going to map every states or every nearest vertices with a different color. The condition is the nearest vertices should not be colored with the same color. The adjacent vertices should not be colored with the same color. So that we are going to find how many maximum number of colors we need to make, to make a color for the given graphs. So that is the meaning of the combinatorial problem. Combinatorial problem solve பண்றதுக்கு we are going to use some certain extra type of constraint with the properties. Then these are all coming under combinatorial problem. It is also to be called as a decision problem. So that in that combinatorial problem, we are looking for an optimized solution. We are not looking only for the feasible solution. We are looking for optimized solution. Optimized is the best solution for the problem. So these are the some of the example applications which is related to the combinatorial problem, like traveling salesman problem, graph coloring problem, scheduling problem, planning applications, internet packet routing applications. These are all coming under combinatorial problems. And the next thing is geometrical problem. So normally this geometrical problems, it's mainly to deal with drawing of geometrical objects. அதாவது என்னன்னா geometrical objects draw பண்ணி அதை நம்ம ஃபைண்ட் பண்ற மாதிரி இருக்கணும். So the basic object என்ன அப்படின்னா like ஒரு point draw பண்ணது, ஒரு arc draw பண்ணது, line draw பண்றது, polygon draw பண்றது. So with the help of this, we are going to make arrangements in our real application area and we are going to solve. நார்மலா ரெண்டு கிளாசிக்கல் அப்ளிகேஷன்ஸ் வந்து இந்த ஜியோமெட்ரிக் ப்ராப்ளத்துக்குள்ள வரும். ஒன்னு வந்து பாத்தீங்கன்னா க்ளோசஸ்ட் பேர் ப்ராப்ளம் அண்ட் செகண்ட் ஒன் வந்து பாத்தீங்க அப்படின்னா இட்ஸ் அ கான்வெக்ஸ் ஹல் ப்ராப்ளம். I will repeat once again. ரெண்டு டைப் ஆஃப் கிளாசிக்கல் ப்ராப்ளம்ஸ் இதுல ஒர்க் ஆகும். ஒன் இஸ் அ க்ளோசஸ்ட் பேர் ப்ராப்ளம், செகண்ட் ஒன் கான்வெக்ஸ் ஹல் ப்ராப்ளம் அப்படின்னு சொல்லுவோம். க்ளோசஸ்ட் பேர் அப்படின்னா we are set of pixels இருக்கும். Pixels means it is a location. அதுல இருந்து நியரஸ்ட் லொகேஷன்ஸ் நம்ம ஐடென்டிஃபை பண்றது க்ளோசஸ்ட் பேர் ப்ராப்ளம் அப்படிங்கிறது. செகண்ட் ஒன் வந்து கான்வெக்ஸ் ஹல் ப்ராப்ளம் அப்படின்னா ஒரு செட் ஆஃப் பாயிண்ட்ஸ்ல வச்சு we are going to identify the polygons. This is called a convex hull problem அப்படின்னு சொல்லுவோம். So geometric problems mainly to deal with geometrical objects. So நீங்க அப்ளிகேஷன்ஸ் நீங்க பிக்சல்ஸா எடுத்துட்டோ அல்லது ஒரு பர்டிகுலர் ஆப்ஜெக்டா எடுத்துட்டோ நீங்க சால்வ் பண்றீங்க அப்படின்னா geometrical problems வரும். So some of the applications என்ன அப்படின்னா we are going to make the computer graphs, அதாவது drawing of objects or animations பண்றது, இது எல்லாமே இது coming under geometrical problems. ரோபோட் மோஷன் பிளானிங், அதாவது ஒரு ரோபோட் வந்து மூவிங் ஆகுது. ஸோ அப்ப அதை வந்து அதாவது ரோபோட் மூவ் ஆகணும் அப்படின்னா நெக்ஸ்ட் பொசிஷன் போகணும் அப்படின்னா இது பேஸ்ட் ஆன் லொகேஷன்ஸ். ஸோ இது கம்மிங் அண்டர் ஜியோமெட்ரிக்கல் ப்ராப்ளம். கிரியேஷன் ஆஃப் கேட்ஸ், சிமுலேஷன், geographical information, GIS, geographical information system, and designing CAD/CAM systems. These are all some of the various application area for geometrical problems. And the next one is called a numerical problem. So normally the numerical problem, it is also called as a numerical analysis. Normally it is deal with for mathematical applications like solving equations, solving fundamental integrals, evaluating functions. These are all coming under numerical problems. But the last 20 to 30 years, this numerical problems are mapping to business applications. So that this is a business application. Nowadays, this business application is a dominating field in our computer science era. So this is a business application like solving. We are going to provide the algorithm for efficient algorithm for information retrieval. We are going to provide the effective storage in cloud platform, and we are going to transportation of many information with less amount of bandwidth. And also we are going to make a presentation to the user with effective manner. So these are some of the business major application areas. Nowadays it will be considered it coming under as a numerical problem. But we can for numerical problems, a maximum number of problems we are looking only for the absorbent solution because of that round of area. But the major application area for this numerical problem is related to scientific and engineering applications. So these are the different kind of numerical application. Important problem areas we are mainly to concentrate in computer science field. I will repeat once again. One for sorting, searching, string application related problems, graph representation problem. Next one is a combinatorial problem. Combinatorial solving is a problem with some certain constraint. Geometrical problem, just we are going to solve with the help of dealing with objects, and the numerical problem for dealing numerical values. So these are the different kind of problem areas we need to concentrate with the help of computer we can able to solve. Thank you.